Hello and welcome to the Vector Podcast. My name is Christian Perez and I'm the founder and CEO of Altivum Inc, creator of Vet ROI, and author of Beyond the Assessment. I started this podcast to help you turn your curiosity into real skills and measurable results. If you caught my first episode, you already know where my focus is here. Strong fundamentals, practical systems, and solutions that genuinely work in the real world. Today, I want to give you a comprehensive introduction to AI and how we got here by discussing the 3 critical technological innovations that had to converge for artificial intelligence as we know it to emerge. So let's start this discussion by going over how AI went from futuristic concept to the transformative force that it is today. See, for many people, it feels like AI sort of arrived overnight. ChatGPT's launch in November of 2022 seemed to come from almost out of nowhere, reaching 100 million users in just 2 months. That's faster than any technology in history. For others, it's honestly overwhelming. So why does this tech revolution feel so different from previous waves? Well, the answer, I believe, lies in convergence, a simultaneous maturation of 3 foundational technologies, each developed over decades that aligned at precisely the right moment. What are these 3 tech innovations? Well, transformer architecture for one, specialized computing hardware, and the explosion of accessible structured data. Transformers in the context of AI are a neural network architecture that was actually introduced by Google's groundbreaking 2017 paper titled "Attention is All You Need." You can find the link to that article in the description below. This architecture fundamentally changed how machines process language through its self-attention mechanism, which allows models to consider every word in a sentence simultaneously, understanding complex relationships, even across thousands of words. You see, before transformers, AI models processed language sequentially. That is to say, word by word, like reading with a finger tracking each and every word. This created bottlenecks and made it nearly impossible to understand long-range dependencies in text. Transformers changed everything by processing all words in parallel, creating what researchers call contextual embeddings. These are mathematical representations that capture not just what a word means, but rather what it means in that specific context. The impact was immediate and profound. Translation accuracy improved dramatically. Google Translate's quality jumped significantly after adopting transformer-based models. More importantly, transformers proved scalable in ways previous architectures just couldn't match, leading directly to the large language models that we use today. The second technological innovation is specialized computing hardware. Now, specifically, I'm referring to graphics processing units, or GPUs, and tensor processing units, or TPUs. Originally designed for rendering video game graphics, GPUs excel at the parallel computations that AI models require. A single modern GPU can perform thousands of calculations simultaneously, compared to traditional CPUs that handle tasks sequentially. NVIDIA's dominance in this space is marked by their incredible feats of engineering. Their H100 chips released in 2022 deliver unprecedented performance for AI workloads, up to 30 times faster than previous generations for certain tasks. A single H100 can cost $25,000 to $40,000, and training the largest models, well, that requires thousands of them working in concert. Google's TPUs, custom built for AI workloads, power their own services and are available actually through Google Cloud. This hardware evolution enabled a crucial shift: the scaling laws that were discovered by researchers at OpenAI and other labs. These laws revealed that model performance improves predictably with 3 factors: more parameters, more training data, and more compute power. GPT-3 has 175 billion parameters. GPT-4 is estimated to have over 1 trillion. This exponential scaling requires exponentially more hardware and cost. The economics are staggering. Training GPT-4 likely cost OpenAI over $100 million in compute alone. Meta's Llama 2 training reportedly consumed 20 million in GPU time. These numbers explain why only a handful of companies can afford to train frontier models, creating a new competitive dynamic in the AI landscape. The third technological innovation is the unprecedented availability and accessibility of structured, high-quality data. This extends, again, beyond the quantity of data. We're talking quality. It's having the right data properly organized and instantly accessible. Vector databases represent a paradigm shift in how we store and retrieve information. Unlike traditional databases that store exact matches, vector databases store embeddings, mathematical representations of meaning that enable semantic search. You can now search for concepts, not just keywords. So query for contract disputes and retrieve relevant legal documents, even if they never use those exact words. Cloud platforms have democratized data processing capabilities that once required massive infrastructure investments. AWS Bedrock provides one-click access to multiple AI models through simple API calls. Google's Document AI can extract structured data from invoices, contracts, and forms with 95% plus accuracy. Oracle's Document Understanding processes thousands of pages per minute, automatically identifying key clauses and compliance issues. The impact on business workflows is transformative. Legal teams can now analyze thousands of contracts in minutes instead of months. Financial analysts can process earnings reports from hundreds of companies simultaneously, and customer service teams can instantly access relevant information from vast knowledge bases. These three technological innovations multiplied each other's impact. Transformers, they needed massive parallel computing to reach their potential. That computing power was wasted without high-quality accessible data to train on, and the data was useless without architectures capable of learning from it effectively. The result is AI that understands context, generates human-quality text, writes functional code, and reasons through complex problems. This convergence explains why AI's arrival feels so sudden and comprehensive. Unlike previous technological waves that improved existing processes incrementally, AI is fundamentally changing what's possible across every industry simultaneously. Now, I hope this information provided you with a better understanding of how we got to where we are today. The technology that powers the truly incredible computations happening when you ask AI to, say, write the response email you would have otherwise started with, as per my last email. Or when you ask AI to generate an image of you in the career of your dreams. Or maybe you ask AI to generate a bedtime story where you and your child are the protagonists. In any case, thank you very much for listening to the Vector Podcast. We covered a lot today. We unpacked why AI's rise feels so sudden, the convergence of transformer architectures, specialized computing hardware, and accessible high-quality data. 3 decades in the making technologies that align to create the most significant technological shift of our generation. More importantly, we explored how this convergence doesn't just represent technical progress, but a fundamental expansion of what's possible when human intelligence meets machine capability. If this episode helped clarify the AI landscape a little bit for you and it sparked ideas for your own applications, please like this episode, subscribe to the Vector Podcast, and share it with someone who's navigating this transformation alongside you. Drop a comment below and tell me, which of these 3 technologies do you find most fascinating? I read every response and will use your insights to shape future episodes. Next time, we're diving into the practical side, a battle-tested framework for implementing AI solutions that deliver measurable results without disrupting the systems and relationships that drive your success. Until then, keep building.